Hi everyone, welcome to our first video by Girls Who Code at Victoria Park. Today we'll go over operators and logic. We'll be doing some example problems, starting from what we think is easiest to the most challenging. But if you find one of these easier than the other, then you can just skip around. We're only going to focus on the basics and the syntax of coding, so if you already know that, then you can skip to another video. But today these are the problems we're going to focus on. So our first problem is we're going to create a variable called seconds. We're going to assign it to a random number and then convert it into hours, minutes, and seconds in this format. For our second problem, we're going to reverse a random integer number. And for our third problem, we're going to do a question similar to CCC's J1 squares. The only thing that's different is that instead of using user input, we're just going to use a random number to focus on the logic of this. So some syntax I'm going to be using, and probably the other executives, is input and output. So let's say you have a program that multiplies a number by 5. The input would be whatever you want the computer to calculate, or what you put in. So let's say 2. The computer would then do 2 times 5, which would be 10, and that's what the computer will output. So for example, if I put number 3 in, it goes through the computer, 3 times 5, which is 15, and then gives us 15. So those are just some basic words that we're going to use frequently. Next, something we're going to use to get the random number is a method called math.random. So it's basically a double value. A double is a decimal in Java between 0.0 and 0.1. More specifically, it would be greater than or equal to 0 and less than 1. Since we want to get a lot of seconds, we're going to manipulate it a bit by adding some numbers and multiplying it, which I'll go into later. So this would be our inputs for all of the questions. And the last thing I want to quickly cover before I start us off with our first question is modulus. So modulus takes the remainder of a number. So I have an example here, 5 divided by 2 is 2, remainder 1. And the modulus would be 1. You can solve this by doing long division too. So if I do 5 divided by 2, 2 goes into 5 2 times to get 4, and then we get 1. So this is the modulus. This is on a small scale, so once we get to the real problem, it might be a bit more challenging to think of, but don't worry. So our first question is converting seconds into time. So this is what you will probably be greeted with whenever you open an IDE. Here you have this public class main. In order to run any program in Java, you need these, or this line of code. Public static void main strings, string, and then these brackets, args, and then these curly brackets. This basically just says this is the beginning of the code, this is the end of the code for this method. We're not going to go into the specifics right now, but just know that you need to have this every time you start a program. Now first we want to generate a random number as our seconds. So we can do int total sec. So I'm just going to use this as the main total seconds. And then I'm going to do math.random, which is the method I briefly went over, times 5900, which will make it large enough for us to calculate, and then add 99 so it looks more random. And of course, you want to end with a semicolon for anything. Now you'll get a bug here, because this, again, will give you a double. But I want to make it an integer here, so it's easier to find. So it's easier to convert it to hours, minutes, and seconds. So a simple solution is just to put int in front in some regular brackets, like this. And in order to see what number we got, to verify our answers, we can just simply output it. The output in Java, you want to do system.out.println, and then we want to make this easier to communicate, so we can add some words. In order to add words, we can have these quotation marks by saying the time is, and then space. I'm adding a space here for formatting reasons because the computer will output exactly what you put. And then to add a variable to this, total sec plus, and then seconds. I added a space here for formatting, and I think it's easier if I show you what it looks like. Explain why I had these plus signs. So it'll give us 123 seconds. And so if we do, oh, I need to mention, Java is similar to a computer. It follows the orders of operation, so it does multiplication first and then addition. But for simplicity or for ease of understanding, I will add brackets so we know that this is going first. So again, if you want to have a random number, there. So I added these plus signs because this is variable. This will change depending on the number. If I have total seconds here, it will actually print total like the words total sec instead of the actual value. So for example, it says total sec here, which is what we don't want. Okay, and then for us to understand in the future, or if you're showing the code to someone else, it's good to put comments. Comments are things that the computer won't read, so you can put, you can explain your code in English. So if I just want to briefly mention, I can just say generating the time in seconds. And as you can see, for single line comments or comments only on one line, I use these double slashes, like so. So now that we have a random number, we basically did this first section. In order to calculate the number of hours from seconds, we can simply use unit conversions, like you would in math. Hours, okay. So let's say we have 1 second. That 1 second will equal a certain amount of hours. And for unit conversions, do 1 second times 1 minute, and there are 60 seconds in a minute, so we can do 60 seconds, 60 minutes in 1 hour, and it will equal blank amount of hours. For unit conversions, we can just cross out the units that are the same. So it would be 1 times 1 times 1 in the numerator, and then in the denominator, it would be 60 times 60. So it will be 1 over 3600. I'm just going to erase this. So 1 second is 1 over 3600th of an hour. And that same logic will apply to our code. So we can just do total seconds divided by 3600 to get the amount of hours. To get the number of hours, we can just do int hours. We want it to be an integer because in this format it should be an integer. Int hours equals total sec divided by 3600. Now what's helpful in this case is that a 1/, what we normally use to say that something is dividing by something else, it does integer division. So no matter what, it will give us an integer number, and so we don't need to convert a double or decimal into an integer. So we save a step. Next, we want to find the amount of minutes. For minutes, we need to use modulus because it's taking the remainder of the hours and dividing it by 60. You don't want to use unit conversions because it will just give you seconds in minutes and it won't consider the amount of hours. By dividing it by the amount of hours and taking the remainder, so to do that, we can use modulus because modulus finds the remainders. And this percentage sign means modulus, so total seconds, hours, so we're taking the amount of the remainder of the hours, this. We want to divide it by 60, because there are 60 minutes in an hour. And then for seconds, this is a bit easier. We can just take total seconds divided by 60 and the remainder of that. So if I want to, I think it's better if I show you with an example how this works out. So we have 1,756 seconds in our random number. To show this, we can do long division to find the remainder. So there's 60 seconds. 60 goes into 175 2 times, so 120. So 60 goes into 75 once, so we can do 60. And then 56 will be have a 0, and then. So normally if you continue, you can do decimals, or 60 does not go into 56, then this is basically our remainder. So that's how we can find seconds. So now that we have hours, minutes, and seconds, we can print it out, the same code that we used here. System.out.print ln. And the more you practice, the more you will memorize this along with this. I always get mixed up with the strings or string, but it's it should be string. So we can just do hours and then plus the colon, so it can be exactly like this format. Minutes plus another colon, and then plus seconds. There is an issue here which I'll get into later, but let's just see if this works. Okay, so we have this down, so we can double check with an online converter. So for our example, we have 5,921 seconds, which gives us 1 hour, 38 minutes, and 41 seconds. Okay, so let's use this and get 5, 1, and it's the same as our code got. So it's 1 hour, 38 minutes, and 41 seconds. I'm gonna try to find another example to explain why this output is not the best. So, okay, so here in this example, the time is. I'm gonna erase this. So the time is 1 hour, 8 minutes and 14 seconds. But as you can see here, if I enlarge it, it's missing a 0 here. So it's supposed to look like this, but right now it looks like this. So how can we solve this? Well, this is something that Irene can get into more detail in the future, but we can just find the first digit and the second digit with division and modulus. So I'm going to call the first digit of minutes D1 equals minutes divided by 10. Integer division divided by 10. in minutes D2, the second digit, which would be 8 in this case, and just find the modulus, and I can prove it soon. And then for the seconds, we have the same issue, so I'll do seconds D1 equals seconds divided by 10, and int seconds D2 equals seconds modulus 10. There are ways you can do this with formatting, so you can just have it on the same line, but right now we're just focused on the logic behind this. So if we do this, we can do minutes D1 plus minutes D2 plus seconds D1 plus seconds D2. Like so. And if we run this, we can use this example, so 149. It gives us 2 minutes and 29 seconds. 2 minutes and 29 seconds. Now I'll try to explain why this works to give us the first digit and second digit very briefly. It actually might be easier for us to print out the minutes individually, so I can show you. m.out.print ln minutes, and then I'll just add a space so you can differentiate. We have 31 and 21. So if I want to do 31, this is the first digit, this is D1, and this is D2. So since we're dividing it by 10, 10 goes into 31 3 times. Here is the first, matches with that, and the remainder matches with the modulus. And again, it's integer division, so the computer for D1 will only read 3 and ignore any decimal places after it, because it's integer division. And we take the 1 and get the modulus of this. So these two are equal, and these two are equal. And that's basically how you can get the first digit and second digit of any number. And so let's just test this one more time. You can delete this. So 3,497 seconds, 58 minutes and 17 seconds, 58 minutes and 17 seconds. So this is basically how we solved the problem in just a few lines. And so I'll just make some comments so it's easier to see. So for this one, you just use this for formatting the digits. This is just the output. And this is just calculating. So you can break this into 4 main parts: the input, the calculations, the formatting, and the output. So this is normally how I think of coding questions when I approach them. I think of what I need to input, or if the user needs to input, what I need to output, and then I think about the calculations. And so yeah, that's basically how you solve the problem, how to convert seconds into hours, minutes, and the remaining seconds.
Alright, so here we have a problem that asks us to reverse a 3-digit integer. For example, if we were given an integer number, if I put this number is equal to 1, 2, 3, then we want a program that could output 3, 2, 1. So let's think through how we might be able to do this. First of all, we know that we want to get the ones digit, so let's have it ones is equal to the ones digit, and now we have to think about how we can manage to do that. Well, maybe we'll have to think about what we can use in math in Java. So we have There's addition, which can't be very useful. Subtraction can't be very useful. Multiplication, maybe. And then you think of division, and that's sort of what you want, but not really what you get, because if you do 1, 2, 3 divided by any amount of number, you're not really going to get the right digit. But then you remember that in Java there is a fifth common sign called the modulo, and what the modulo does is that it gives you the remainder of a number. So you might be able to realize that if we were to take 1, 2, 3 and we use the modulo of 10, then the closest divisible number of 123 is 120, because 120 is divisible by 10, and after that you get 130, and 130 is larger than 123, so smallest divisible number is 120. So what the modulo does is that it's going to take 123 and it's essentially going to subtract 120, and it's going to give you the remainder of this division. It's going to give you the remainder of 123 divided by 10. And in this case, the remainder happens to be 3, which is exactly what we want, right? We're looking for the ones digit, and that's 3. And if you think about it, this would work no matter what the number is. If you had 154, then and modulo 10, the closest number to 154 that is divisible by 10 is 150. So you would get, from 154 modulo 10, you would get 4. So that's why we could take our ones digit, we could say number modulo 10, and that would give you our ones digit. That would give us our 3 here. Next, we want the tens digit. And the logical idea would be to repeat what we just had. So number modulo, but instead of 10 we want 100, because but now let's think about what that does, right? The closest number that is divisible by 123, that is divisible by 100, is 100. So if we had 123 modulo 100, what that would do is that would give us 123 minus 100, and that gives us 23. That's not really what we want. We want not 23, we only want 20. But we already have our ones digit, so maybe you could realize that if we were to take number modulo 100 and we were to subtract the ones digit from it, then tens would then be equal to 20. So this would gives us 3, and this gives us 20. And then you think of hundreds. How might we get the hundredths digit of the number 123? Maybe you think of hundreds is equal to a number modulo 1000, but that does not seem to really work. The closest number divisible by 1000, well, there isn't a number divisible by 1000 in 123, so you would get 123. So we're back to the beginning. So clearly modulo 1000 is not our solution. However, if you think, what did I do last time? I subtracted the ones digit from here. Well, maybe you'd realize that we already have the 3, we already have the 20, and if we were just to take the number 123, subtract the 20, subtract the tens, and subtract the 3, subtract the ones, then that would just give us what we want, because that would give us 100, and that gives us a digit we want. So now we have 3, we have 20, we have 100. It's split between the 3 digits we want. We have 3 numbers, 3 integers, so each integer has a digit. And then what we might think of, now how do we reverse it? We have all 3 integers split apart. Why is that useful to us? Maybe you would realize then that what we want is 3, 2, 1, or 300 plus 20 plus 1, as that is how 3-digit numbers are made. So you could do int, so our output number would be equal to, so we want 300, that's 3, that's our ones digit, times 100. We want 20, 20 is a tens digit, we don't need to change it. And then we want 1, which is our hundreds digit, but right now it's stored as 100. So if we were to do divided by 100, then we would get exactly the right number 1. And now let's see if we are correct. So I'm just going to print out what the output is into over here. And it gives me 321. Perfect. So we have 1, 2, 3, and it turns to 321. Now, let's see if this works for every 3-digit integer. If we were to try something like 942. $249. Perfect. So now we know that our code probably works. And if you wanted to try some more extreme situations, you could try 100, the smallest 3-digit integer, and that gives us 1, right? 001. If we were to try 999, well, it should still give us 999. And it does. So we can see that this works out. In future problems, you can always think of integers in this way. So always split integers as 100 plus 10, 100 times an amount plus 10 times an amount plus 1 times an amount. That's often useful in problems, especially problems that tell you to split apart, to like change the digits in some way. So always think if you can use modulo 10 or modulo 100 or something like that to proceed with your problem. And also, this program doesn't have to be limited to 3-digit number. If I were to try to reverse a 4-digit integer, I would just add int thousands, which is equal to number. So minus hundreds, minus tens, minus ones, and my hundreds number would have to be modulo 1000 because now there actually is a 1000 to subtract, to take away from, essentially. And as for my output, I'm going to take the ones, I'm going to turn that into 1000 because I need my ones digit to go from here to here. And then as for my tens digit, I can't leave it alone anymore because actually I want my tens digit to go from here to here. It's not staying in the same location. So I'm going to do divided by 10 multiplied by 100. So dividing it by 10 gets it back to over here, and multiplying by 100 moves it 2 digits over here. This might be a little abstract to think about. In general, if you're having a little trouble thinking of a number as a variable where any number can go into it, just try putting in a concrete example. So in this case, my tens would be 30. 30 divided by 10, that's 3. 3 times 100, that's 300. And the number we are trying to get from 1, 2, 3, 4, we want to change that into 4, 3, 2, 1. So yes, we do want 300. Same thing for our hundreds. We want to divide it by 10 by 100 and multiply it by 10 to move it from the 3rd digit location to the 2nd. Go from 1, 2, 3, 4 to 4, 3, 2, 1. And lastly, we want to add thousands and divide it by 1000 to move it to the ones location. And if I were to try this code, it also works. So you can see that this code can be modified into more digits, less digits. You can go from any number of digits that you want. I hope that this problem explained how to do this problem, and that you can gain a better understanding of how to use modulo and other math in Java and coding in general. Remember that it's not that daunting. It's this kind of the same as algebra. You're still using variables. You just need to think through the problem, how to get to what we are trying to get to. Yeah.
So we have to ideally just solve this using the util tab package with the math class. So what we're going to do first is, let's just read it and see what happens. So there's square. She has a collection of equal sized square tiles and she wants to arrange them to form the largest side length possible. So what I like to do is I like to visualize first. We're going to do one of their examples. Let's say she has 9 tiles and she needs to build a square. So the square is going to have equal length sides. So here we have a 3 by 3 and there's 9 in total. So now they're saying, they're asking what's the maximum side length. So here we can obviously see the maximum side length is going to be 3 in order to have this perfect square. And notice that 9 itself is a perfect square. 9 is 3 squared. And so now they're going to tell us that when she has 8 tiles, she can only build a side length of 2. So let's visualize this again. So with 8 tiles, in order to have a square, like a square with equal side length, you will notice that she can only have 2. So now this would be 4 tiles, but she cannot utilize all of the squares, because then if she had another square here and then another square here, so she had a 3 by 3 actually, well this is 9 and she only has 8. So we have to round down to the nearest amount of tiles that she can actually make to form a square. So if the next possible square is a 3 by 3, which is 9 tiles, she can't make that. So she has to do the minimum amount. She has to do the smallest square with 2 by 2. So now she has 4 tiles here, 4 tiles, and that means that she can build a smaller square. And she has to set aside 4 tiles. So here's 4 tiles that she has set aside to make this perfect square. So notice here 8 is not a perfect square, but 4 is. So 4 is 2 squared. And 2 corresponds with the amount of side lengths that she has. So I hope you can see that there's a pattern forming. It's that what the question is really asking you is find the number that when squared gives you the total amount of tiles, or find the number, so 2 in this case, find the number 2 when squared gives you either a number less than the number of tiles that they give you or equal to. So in this case, 2 squared is 4 and 4 is less than 8, so that means we need 4 tiles and we have 8 tiles here, so we can make this square, and this is the maximum, this is the largest square we can make, which is 2 by 2. And so what I originally went about solving this was I used a U loop and I just did some stuff with loop work, but since this is only with math, we have to just use the math class. So in the util package, there comes the math class. And so in this math class, there's a lot of tools we can use there, but we're going to focus on floor and we're going to focus on square root. So the pattern that I noticed was that we can first of all use whatever input that they give us. Let's say input is 9, and we know that we can square root 9 to be 3, which corresponds to the largest side, or even just a side. Since it's a square, they all have the same side, so it's just the side really. And then with 8, if they give us 8, then we can square root 8 and we will get about 2.82. And what it's telling us here is that we should print out that it has a side length of 2. So we'll see that, oh okay, well even though this rounds to 3, we only want to print the lower rounded value. So the floor function, what it will do is it will round down to the nearest integer. So it's going to give us 2. And actually math.floor, it's important to note, math.floor, that returns a double. So this question is asking for integers, so that's going to be important later. We're going to have to convert a double to an integer. But basically the logic here is that you'll take whatever input n that they give you, and then you will have to square that n, so you'll have to say dot square root of n, and this square root is going to give you a double as well. And then you will have to floor this, so you're going to have to round it down to, instead of 3, it's going to round down to 2, which is the maximum side length that you can have for 2 by 2, which would be 4 tiles, which is less than the 8 tiles that you have. And say math.floor this result. And then we're going to have to turn this into an integer, which if you don't know, we're just going to write int there. and that is when you're converting from a from a more accurate data type to a less accurate. So double is more accurate since it has decimal places than integer. So when you're going from more accurate to less accurate, then you will put it in brackets like this and next to that. But we can talk more in detail about that when it has more applications than what we're doing. But basically, this is how you would convert from a double or float for that matter, since float is also decimals, to integer, is you would just wrap it with brackets next to that.
So now we're gonna use the logic that we talked about previously, and we are going to code this question. So first we're gonna need the util package. So let me just, I'm going to import the java.util .star package. So we're just going to import the util package because it has the math classes that we need to perform math operations. So notice how I put a star here. That just means we're importing the whole package. Sometimes you'll see people have other stuff here when they want just a specific class, but if I would just want the whole package, I will just put the star there. So I'm going to say public class, the name of our class, which is GOG, and now we're going to say public static void main string args, and now we are going to get our scanner ready. So to take input, we're just going to have the name of the scanner class, which comes from the util package. We're going to name our scanner. So I like calling it X. You don't have to use X, but that's just what I call it. Scanner X is equal to I'm going to new scanner system dot in. And there we have created a scanner object from the scanner class. So we can now use this object X, our object X, to take input. So they're going to input us an integer. So we're going to say int, say n is equal to x dot next int. I'll make this a little bit neater. Equals x dot next int. And then we're just going to use the the work that we talked about before. So we can just start printing directly after this. So system.out.println, and we're gonna print the text first that they tell us. What I like to do is sometimes it's a little bit annoying to type all this. So you're just going to copy and paste this into quotations like that. And then don't forget, when we're printing a string along with a number or combining anything, you need to put a plus, and then we're going to print the number of the lowest side length. We're just going to input what we talked about before. So int, to turn it into an int, I'm going to say math dot. Notice how I put a capital M? That's calling on the math class within the util package. So you have to put a capital M period followed by the object from the class that you want to use. So we're going to use floor, and it'll bring it up right here, floor. Oh, you need brackets too. And then we need to put the thing that we want to floor within these brackets. So the thing that we want to floor is the math dot, the square root of our number n. And then let's just make sure that all these brackets line up. So that looks about right. And then here at the end of it. So let's just put in a period real quick. And what we're gonna do is gonna get into this pair of brackets and then say plus period. And let's just test our code. So let's test 8, just to make things interesting. So square, largest side of the square is 2, and then let's just throw this in to here. Here we have this, and I like to work with Java 8. If you work with Java 17, I think it makes the runtime seem longer, even though you have your same code. So I just recommend sticking with Java 8. Let's just see. Okay, we got pretty good test cases, so that's cool.